Hello all, my name is Agre, and today we will be looking at binding and posing on a custom character inside Unreal Engine. So let us have a look at today's learning objective. We will be using Mixamo's auto rigger to rig a custom character. We have also prepared an SKD character inside Blender. We'll also import that inside Mixamo, and we'll try to export some Mixamo animations, which we later will be using it for our projects. Along with that, how to set up a third-person project, replacing an Unreal Engine mannequin with a very own custom character, setting up player inputs with the help of animation blueprint, blend spaces, and state machines. So by the end of the session, you will be able to develop a complete locomotion system. Let's begin. Firstly, we will head to Mixamo. If you need animations for your project, there is no easier tool than Mixamo. Firstly, already signed up for Mixamo. If you have not, make sure that you sign up with your social credentials. So we'll browse characters. Firstly, as you can see, Mixamo provides many options for us to choose from. But for our today's session, we'll be using a custom character. So we will head to upload character, select a character file, and I've already prepared the FBXs. So let us import this one first. Open. So depending on the complexity of the character or how dense the mesh is, it may take some time to upload and process the character. So we will wait for it. As you can see, our character is now been uploaded. Now we'll be using auto rigger feature of Mixamo's. We'll click on next. It is asking us to put some markers over the region to the respective areas. So I'll be putting this chin for my character's chin, wrist, near the wrist, elbows, roughly here, knees, and last would be groin. So this is basically asking us to make sure that you mark all these markers, place them properly, because this will eventually create a rig for us. And we do not need any skeleton already, so we'll keep that as standard. And we will hit next. Like I said earlier, it may take some few minutes depending on the complexity of the character. And once it's done, hopefully it shows us a rig character. As you can see, our character is ready. It has a preview animation applied to it. And just looking if our character is properly imported. Yeah. We'll hit next. And someone is asking us to upload a character. And it will not save a previous character. I'm fine with it. Hit next. Now, after a character has been uploaded, and now we can use Mixamo's vast animation library. But before using the animations, we need to download this character so that we can use this data in Unreal Engine. So we'll go to download. I'm picking FBX. And for the post, I'll download the original post. It's on download. Let it download. once the character FBX has been downloaded, let's go to animations tab so that we can use animations. Like I said, Mixamo has vast animation library. You can pick any of them which are free to use for your projects. So let's say you want to use hip hop dancing. If I just click on it, I get this. Pretty cool, right? Yeah. You have certain settings for each animation. Do you want style? You want to change the character arm space? You can do that. Yeah. So for today's session, we'll be importing some basic locomotion system, the different states for them, which is idle, walk, run, jump. So before getting started, or rather downloading all these animations, I would also like to show you how you can import your very own custom rigged skilled character inside Mixamo. So for that, let me just head to Blender. You can use any DCC tool. We have a character that has this bone structure over here. Hierarchy is already there. And if we go to a pose mode, as you could see, it is already skinned. So in order to export from any DCC tool, in my case, I am using Blender. So make sure that you go to your object mode, select all. Make sure that you select your skeletal mesh, which is the rig, and the mesh itself. So go to File, Export, File, Export, FBX. If your character has materials and textures, go to Path Mode, click on the drop down, switch to Copy, and make sure that you hit Embed Textures on. I'll limit my export to only selected objects. You scroll down, you make sure that armature is there, and if you want to export any animations, you can. Give it a name, signature, skinned mesh. So hit on export. Once it has been exported, we can go back to our Mixamo and upload a new character. But this time, we'll be importing a soldier skinned. Hit on it. Open. If you remember earlier, we were using Mixamo's auto rigger, right? Now, what we have done is we have uploaded our skinned rigged character. You'll see the difference, what happens. As I said earlier, when we uploaded, it was without a rig. Now we could see that we have uploaded a custom rig skeleton mesh, and it is no longer asking us to use or rather place Mixamo's markers. Now we can start using the animations which we want to use for our project. So firstly, let us look for idle. So I search idle, enter. We have many animations over here to choose from. So you can pick this idle animation and it will be applied to your character. Give it some movement. If you feel like you want to use this for your project, you can. But for today's session, I have already downloaded some of the animations. Let me just pick a noun idle. So let's say if I go to this, it will update in a minute. And this is pretty cool. I want to download this. Hit on download. Now we'll set to FBX. In this case, we want it with skill. I'll keep the rest of the settings default. Hit download. Now after idle, we need walk. I'll just search for walking. You can pick this. Now, as you could see that it is moving ahead, what we want is in place. So check this checkbox in place, and now it is walking in place. If you feel like the character's arm are clipping, you could increase the arm space. Yeah. Take hold. And then hit download. Next is running. So search for running. And I like this one. Click on this. Also in place. I'm pretty happy with this. Hit download again. Now we have downloaded idle, walk, running. Next is jump. So if I go for jumping, this is pretty tricky, right? Because in games, we could just use this, but the problem would be it's a full animation of jump. What we want is we want more of a breakdown. So something like this, where we are only jumping up, jumping down. But if we go down, we have this, where it is in place and it is only jumping, where we'll be using blend states to blend between each and other states, right? So hit jumping up, hit on download. Same goes for jumping down. Edit update. Hit on download. Now we will also need one more animation which is falling idle. Why? Because we want the character in air. We want to check whether the character is in air. So we have the state, which is falling idle, the first one. And then hit download. We make sure that all the settings are kept as it is. Hit download. Now we need to hop onto Unreal Engine. Yeah. So let me just show you what project settings we need to keep. Click on new project. I have chosen a games template. In games, we have third-person template. Give it a project location, provide a name for it, and that's it. If you have not downloaded Unreal Engine, please make sure that you do that, because the very first time you'll be creating a project, it may take some time. And I have already created a project. So this is how Unreal Engine interface will look like. And we have a viewport, we have windows which are responsible to import our characters, organization. Yeah. Now, if we hit play, by the way, I'm using Unreal Engine 5.7, which is latest at the time of recording. Once we play, we could see we have a third-person character, which we can control. It can walk, can run, can jump as well. What we want is, our main objective is to replace this functionality with our very own custom character, which we just downloaded. Hit escape. We need to import our character, which we downloaded from Mixamo, and animations as well. Before importing them, organization is the key. Right click, create a folder name. I'll call this character, or rather my character. Inside that, I'll be creating 3 folders. First would be meshes. Next would be animations. And the last one would be blueprints. Yeah. Now we'll go into the meshes folder and we'll import the exported character from Mixamo. So this is the character which I had exported. So we also have our animations. I've already prepared them earlier. So we'll first import our character. So drag and drop it inside Unreal Engine. We take a moment. We'll be using default pipelines, and we'll just cross check that we are importing a mesh, import. Now, the character which I've imported also has some material instances. Yeah, we'll give it a moment for it, and then we'll just organize a bit. So what we'll do is, we will create a new folder inside your meshes. It will be called materials. Rename it. Materials. Go to your meshes. Go on, select, and then drag and drop all the materials into your meshes folder. Over here, I'll turn off my filter and go back to my meshes folder. As you could see, we have imported a character, but we also got 2 different asset types. So if I double click on it, We are now in a skeleton mesh editor window. A character is there, which is in its original pose. We also, along with that, we also got a physics actor, and a skeleton tree is also there. Very cool. Let us import our animations. We'll go to our map character, animations, go to my folder, and we'll drag and drop all the animations which we want. Drag and drop. Now, there are a few settings which we need to change. Firstly, we need to make sure that the animations which we have imported is for a character skeleton. So we click on skeleton and pick character skeleton, which we just imported now. And also, we know that we have only importing animations, so we'll make sure that we check import only animations. Scroll down, cross check, animations are getting imported, and then hit import. See, all my animations will be imported. I'll give it some moment. As we can see, most of our animations are imported. We'll wait for the last two. Any moment now. Yeah. All animations are imported. I'll just save all. Selected. Now, if I open our animation, you could see our animation has been imported. And just see. We have an asset browser where you could see all our animations are there. Just cross-checking them if it has been imported or not. Yes. All okay. Now, we'll go to our My Characters. Inside that, we'll go to Blueprints folder. We need to create an animation blueprint. Go to right-click, Animation Blueprint. It is asking us to create an animation blueprint for a specific skeleton. We want it for our skeleton. So we'll be picking up character skeleton, hit create, and I'll call this as PP A P animation blueprint underscore character. So yeah. What is animation blueprint? Let us look at it. An animation blueprint is a visual scripting system used to control how a character or skeleton mesh moves and animates in real time. Think of it as a brain of a character's animation. It decides which animation plays, when it blends, and why it blends. How does it do it? It controls movement animations such as idle walk and blends these animations smoothly based on the player inputs or game's logic. there are three integral or core parts of animation blueprint, which is anim graph, state machine, and event graph. We'll have a look at them later on. Why do we use animation blueprint, right? It makes a character feels alive. It is an essential core part of games and cinematics because it handles the animation logic and the movement logic for game. So coming back to animation blueprint, before getting started with the animation blueprint, we need to set up a character. As we all know that we have used a third-person character blueprint. So we'll go to third person. Blueprints. Then we'll bring on the blueprint class of the third-person character. We have the logic for jump, movement, everything set up. Okay. So we go to a viewport. As you could see, this is a Unreal Engine mannequin. Now what we want is we want to replace this with a custom character. So to do that, I select my character, mesh. In the details panel, go to your mesh, skeleton mesh asset, click on the drop down and search for character. Because I have named my character as character, I click on it. It will get updated. As you could see, my character height is a bit taller than the Unreal's default one. We need to make sure that it fits within this capsule collider. So what I'll do is I'll scale this down a bit. So scale, move to select, I'm going to say 0.9 overall. I'm happy with this for now. I'll just hit compile. Now, what we also need to do is we want to use or set up some input system where we could use, let's say, a shift key where a character can run. So we'll go to our event graph of the third-person character blueprint. Scroll down. To navigate inside the event graph, right-click and pan. Hold your right-click and pan. As right-click and search for left shift as an event. And we want to call the character movement, which houses our input or rather the movement of our character. Drag and drop. From here, we will search for max for set max speed, set max speed. So once we press up set max speed, we need to set a value. What are the default values? If you do not know, we go to a character moment, go to the details file and search for max speed. You could see that the max walk speed is currently set to 600, which is too much for her. Now we'll set it to 300. And once we press a left key, we want it to go to 600 so that it could run. And we also want when we release it, so we'll duplicate our walk speed, keep the target, the character movement, and we set the value 300. So what this will do is when we press a left shift key, it will run. Once we release it, it will go back to its maximum walking speed. If compiled, one last thing which we want to do is go to a character. We need to make sure that it now also looks at our animation blueprint class, which we just created. So click on anim class and search for AV character. Hit compile, save, and let us have a look if it has updated or not. Hit on play. You could see that we have a character. It can walk. If I press shift, it is going faster. It's not walking, it is just moving ahead. So if I leave my shift key, it is now going to a normal speed. Now what we need to do is we need to set up our characters walking animation logic. So we'll go to my character folder, go to blueprints, and we'll double click our animation blueprint. Now this is the interface of animation blueprint. We have our anim graph and also the event graph where we'll be creating the logic behind the character's movement. So by any chance, if you might close the tabs, just double click on the event graph and anim graph, you'll be able to find. First, we will deal with anim event graphs. Now, we will add over here event begin play. And we want from a form character, we want to cast to a third person character. So we will search for cast third person character, connect this executable to the executable, and we will keep a reference of a third person character. So right click over here, promote to variable, and give it a variable name as character reference. So what we just did now is whenever this, so even begin play, we will have a look what it does. It is called when the game begins, and we have just casted that we want to check that we are only controlling a third person character, and we just stored a reference in the variable form, which is called as character reference. Hit compile. Now, we will call a character reference, which is get a reference out of it. Because the character reference now stores all the references of a character, which we want is the speed and the character's movement. So from here, we will search get velocity. Go down, get velocity. And we will also try to get what is the length. So we'll say get vector search for vector length. Yeah. And now we will promote this to variable and call this variable as speed. This will be our speed variable, which will control the speed of a character. And we want it to move or rather check every updated frame. So we'll be using this from our character reference. We will call if it is valid update blueprint, and if it is valid, we will update the speed. If not, we'll do nothing. Now, we also need to cross-check whether our character is following or not. So we'll be using character reference. From here, we'll search for get character movement. And Unreal has created a function which is called is falling, which is under nav movement. All it has a return value of Boolean. So what we'll do is we'll just promote this to a variable and call this variable as is falling. Hit enter and connect this to your update blueprint. So yeah, this was pretty much the logic behind the animation blueprint event graph. So let us have a look at what all nodes we covered. Yeah, so that's easy for you to understand. Let's just hit on save. So we were looking at animation blueprint and the is falling. So yeah, this pretty much covers the animation blueprint. And we could also go now to our anim graph. Create a state machine. Like what is a state machine? We'll have a look at it. So just state machine. It is asking me to name it. We'll give it a name for it, locomotion, and connect the pin to the out. Yeah. Hit compile. We'll get some warnings because we haven't done anything. What is a state machine? Let us have a look at it. A state machine is basically a system where inside animation blueprint, what it does is it allows us to go from one state to another or switches between one state to another. It uses variables such as in our case it will be speed or it's falling, and if the condition is met true, it will switch to a different state. So for example, if you're walking, or rather in your default state is you're currently in idle, and if it is greater than 0, you can walk. Same goes for run, same goes for jump. Why it matters? It basically handles all the animation logic and makes it manageable for us to have a essential locomotion system, which eventually by the end you'll be able to transition from one state to another. If you're walking, if you're running, you can transition from one state to another. So yeah, that is what state machine is. Back to this. As we have created a state machine, if you double click on it, it was giving us a warning because there's nothing connected to an empty state. Empty state is basically our default state. So our default state of a character would be, in my case, it will be an idle state, which is the idle animation. So what we can do is right click, create a state, call it as idle. Connect this to this. And inside our idle, it is looking for an animation pose. We go to asset browser, we could see all our animations list, and I'll just connect or drag and drop my idle state and connect this to our output animation pose. Hit compile, and we could see a snap, and it updates that our animation is now currently playing. And just hit save. It also can cross-check in game mode. So hit play, and we could see a character in default animation state. Yeah. I noticed that a character has stopped animating because a character is not in loopable state, or rather, our animation is not in loopable state. So click on the animation, Scroll down to animation. Hit check. Compile again. So now it will be a loopable animation. Yeah. Now we need to go from idle to walk. So what we could do is go to search for. There are, like earlier we saw cyclic state. We could also directly drag and drop our animation. So in our case would be cat to walk. Give it a state name or walk. And if I double click on it, it would see that automatically a cat animation has been applied to it. So go back, we'll do a transition, drag this idle to walk, and walk to idle. So we have created these two transitions. If compile, we'll get a warning. Obviously, the warning is due to because we do not have any transition code in between idle to walk and walk to idle. So if I click on it, we need a transition. So for idle to walk, what we could do is we could use our speed variable get, and from here we could drag and drop and search for greater than equal to. So let's say in our case it would be if the speed is value is greater than 2, you can transition to a different state. Let's compile, go back, we'll do same for walk to idle, double click on it, get the speed, drag. In this case, it will be less than equal to, I keep a value of 1, drag and drop. But now we no longer get any warnings. Save. If we minimize, and let's say we see what happens, we could see that a character is in default state, which is idle. It is a loopable animation. And if I walk, it is walking, but the animation is not playing. So to fix that, go back to our animation blueprint, go to your walk state, double click on it, click on the character walk, change it to loop animation. Compile, save. And if I see that it has idle state, it walks, pretty good. Now let us build on this. We need, let's say we want it to run. So we double click on it. Now when we are in a walk state, this is tricky, where we cannot add two different animations in one state. So if let's say I add run and I just connect it, it will replace it. This is how it will not work. So to do that, what we need is a blend space. So go back, hit compile. What we have done is we'll get rid of the walk state which we just created. Delete, compile, minimize. Go to your My Characters Blueprints folder, right click, animation, blend space. We have blend spaces, and if we go to a legacy, we have blend space 1D. You can pick either one what are they? Let us have a look at it. Also, we saw the blueprint notes, which we hadn't looked. So we'll go through them first. The very first blueprint which we node we had was begin play. It basically runs that whenever the character or rather the game is done. And along with that, we also use the third person character, which always checks whether we are calling to a character blueprint or not. Again, which is basically a communication between a character's logic and animation's logic. Along with that, we also stored and promoted to a variable called as character reference, which basically stores the cast property of a third person character to get access of the movement values inside our animation blueprint. Along with that, we also saw a blueprint update animation node where which executes every updated frame. Right? So anything related with speed, falling, jumping can be done within an instant with the help of blueprint update animation. We also created two different variables where we wanted a speed variable, which is a float value, which checks whether a character is walking or not with a different value. If it is a low value, which is 0, it is an ideal speed. If it is a mid value, let's say 1, it can walk. Same goes with run as well. And the last variable which we created was Boolean, which is falling. We give it a name, which basically cross-checks whether a character is falling or not. And if it is, we can switch between different animations, whether it should be jump, or whether it should fall, or return to ground state. Now, we were talking about blend spaces. We have two options in blend spaces, in which blend space 1D and blend spaces. Now, blend space is a system which blends animation using only one input parameter, which uses only a single axis, which its common parameter would be useful for usually for speed. How it does it transitions between ideal walk with a forward locomotion and with a gradual speed. It will be useful only for horizontal axis, or rather only one particular axis. Why it matters? Because it helps us to do a smoother transition from one state to another. Also makes it natural looking, reduces the animation logic. So that was one blend space 1D. Next, which is blend space, which also uses two input parameters, which are horizontal and vertical axis. And the common parameters would be useful for speed and direction, where you could not only you could go for forward animation, you could also go backwards, strafing, left, right. Why it matters, it becomes the cohesive 360 character movement, which is useful in a professional AAA third person or shooter game, which makes a character more responsive. So that were blend space 1D and blend spaces. If you go back to Unreal Engine, right click, go to animation, click on blend spaces. It is asking you to pick a skeleton, hit on character skeleton. I'll say PS underscore character. Double click on it. This is the interface of blend space. We have a character in a pose. We have the axis window. We also have an animations browser. Over here, I've picked blend spaces for two axes, but I'll be using only one axis. We'll go to horizontal axis. Give a name of speed. And if you remember that we had said the minimum walk speed should be 300 and maximum should be 600. So I'll set the value to 600 and 300. Hit enter. Now, Let us drag our animation. So from walk. So I'll just click on walk over here, keep it over here. So currently it is in walking state, and then it goes to a run state. In order to move, hold your control and see whether if it is blending or not. I could see that the character is blending properly. If it is not, we could also use something, let's say smooth timing, or rather if you want to give weight to the blend space. So if let's say if I increase the blend space to 12 of weight, you could see we have now a drag. It has a weight to the blending. Hit 0. Keep the default values because I'm happy with my default values. Yeah, pretty cool. Hit on save. We go back to our animation blueprint. And now, if you could see in our asset browser, we have now blend space character which we just created. We'll drag and drop it. Give it a name as walk and run. I double click on it. And it is looking for the parameters which we created. And what we could do is we could use a variable which will be our parameter value, which we have already set in our blend space, which is 300 and 600. It compile. Let us go back to our locomotion state machine. Let's connect idle to walk and then walk and run. Like it. Now you guessed it, we need to make sure that it has a transition rule from idle to walk. We'll be doing the same thing. Picking our speed variable, get, and what will do the rule? If it is greater than equal to, let's say 5, we want it to transition to a different state. Compile, go back from walk to idle. Again, we'll be using a speed variable, get. In this case now, it will be less than equal to the value of, let's say, 4, and can enter the transition. Compile, save. We'll minimize this and we'll just cross-check in again if it is working properly or not. Let's save. I could see my character is in idle state. It can walk. And if I press shift, it can run. Going back to walk, it can run as walk, run. Pretty cool. Now, we have 2 problems. Let us have a look at the first one. If you could see, I'm currently in my idle state. And if I press jump, it is going to its walking state. We wanted to use a jump mechanics. So, hit escape. We'll go back to our animation blueprint. To locomotion, we have jumping up. Keep it as it is. Jumping down. And we also have falling idle. Hit enter. We want to do a transition from idle to jump, up, from jumping up to falling idle, from falling idle to jumping down, and going back to idle state. So let us just organize them. Yeah. So now, from idle to jumping, we'll need to set a transition rule. So if we double click on it, we have already created a Boolean. So we could just check if a character is falling, which means it is jumping. So just hit on is falling yet. Just connect this to enter transition. So if it is falling, which means it is jumping, it can enter a jump state. Go back to locomotion. From jumping down to idle, double click on the transition rule. It will be using is falling again. But now they are not falling. So we'll just search for not Boolean and connect it. Hit compile. We have a warning because we are left with the other two as well. Now, in this case, from jumping up to falling idle, we'll double click on it. We need to use time remaining. We have two time remaining options. We will be using ratio. And if it is less than equal to 0.2, we can transition to the other state. So what this does is, we basically just checking whether our previous animation is almost over, then we can transition to a different state. So in our case, if your jumping up is done, and then we can switch to falling idle. So we'll go back and we'll do the same for falling idle to jumping down. Search for time remaining. Less than equal to 0.2. This value can vary depending on the length of your animation. It's a trial and error. I have already cross-checked the 0.2 value works. If you want, we can change the values to 0.3 or 0.4 to check whether our previous animation has replayed or not. So, and just hit enter. Compile. Go back to our locomotion. Most of it is done. And just hit save. Let us see. It is in idle state. It is walking. It is running. And if I now hit spacebar, it jumps as well. Pretty cool. Let's say if I walk, I run. Now if I jump, it is not doing. We need to make sure that we update. So as you could see, is running, but is jumping as well in our idle state. But whilst we are running, and when I press jump, it is not done. So let's fix that. And go back to our animation blueprint. And now from walk and run, we need a state. We could use falling idle again. We could use any other state as well. But I'll just use this from walk to falling idle, and then falling idle to falling idle. From jump, from walk to jump, falling idle would be a transition tool we could use because it is jumping. So yes, we'll use is falling. Check, compile, save, go back. And from falling idle to we will be using the same time remaining ratio falling idle, return value less than equal to. I'm using the same number. You can change these values depending on your character's animation length. Connect the transition, hit compile, save. Now if we cross check, display, a character walks, it runs, it jumps in idles from 8. Yeah. So if I run as well, I could jump it. Pretty cool. So I could run now, could run anywhere, and then if I hit jump, then I can walk. So yeah, if we go back to a locomotion animation blueprint, we see this is what state machine will be doing. Okay, we are creating all these states and we are creating these transition rules, which are basic transition rules, whether our speed is greater than or less than. Same goes for if you are jumping or falling, if it is true or not. And then we are just doing basic transitions with the help of animation blueprint, with the help of our state machines, and also with the help of blend spaces, because like I shown earlier, we were not able to add 2 different animations in one state. So that's why we use blend spaces, which allows us to use multiple animations and blends between them. So yeah, you could also add or build on this. You could, let's say, from falling idle, walk and run, we can drag, and let's say you could use, if it is not jumping now, so you get is falling, search, not Boolean, because it is not falling, then connect. Hit compile, save, minimize, first check whether it is working properly or not. Jump. It is doing what it needs to do. So yeah, this is what binding and posing of your custom character inside Unreal Engine was. Hopefully, you all were able to understand what I was trying to teach, and see you next time. Bye-bye. Take care.